Hi Rangers, today we're going to be learning about parent functions. So we have three parent functions that we're going to be focusing on in Algebra 1. So the first parent function is the linear parent function, and it has a parent equation of y equals x. Okay, a few characteristics about the graph of the parent function y equals x is that it is increasing. It has a positive slope. It goes through the origin. Which means that its x and y intercept are 0, 0. Okay, then when we're talking about our domain and range, okay, domain is our x values. So this is going to end up going all the way to the negative x values, negative infinity, all the way to positive infinity. So the domain is going to be all real numbers. Okay, the range, it's the y values, so it's going to keep going down forever to negative infinity and up. So the range is also all real numbers. Now, looking at the equations, okay, we need to be able to identify that these are linear functions just by looking at the equations, and being able to determine that the parent equation is y equals x. Okay, looking at the graph, again, we need to be able to determine that it's a linear function. Again, linear has the word line in there, so that kind of helps us remember that linear functions are lines. Looking at this example, it's going up from left to right, which means it's increasing. And it has a positive slope. Looking at the second example, it is going down from left to right, which means it's decreasing. And it has a negative slope. Okay, our next parent function we're going to talk about is the quadratic parent function. Okay, the parent equation is y equals x squared. So a few things about the parent function graph is that it is opening up, which means it has a minimum point. It touches the origin. Which again means that the x and y intercept is 0, 0. Okay, this one only crosses or touches the x-axis one time, so therefore this has one x-intercept, which is 0, 0. The domain would be all real numbers. Okay, because it's going to keep going to the left forever and keep going to the right forever. So the domain is all real numbers. The range, though, is going to change because it's only x values that are greater than or equal to that minimum point. So it's y is greater than or equal to 0, which is that minimum value. Okay, looking at our two examples, we're given the equation in a graph. We need to be able to determine that how they open. So this first one opens up, the second one opens down. Okay, we also need to be able to determine that if it opens up, that means it has a minimum. If it opens down, that means it has a maximum. Okay, now moving on to the exponential functions, and then we're going to compare the three equations. So exponential equation its parent function or parent equation is in the form of, okay, so the numbers can vary on this one, but it's in the form of y equals ab to the x. Okay, the x is the exponent, and exponential has the word exponent in the name. Okay, the parent function is going up from left to right, which means it's increasing, or we call this exponential growth. Okay, it's not touching the x-axis, so the domain is again all real numbers because it's going to keep going in both directions forever and ever. But the range is what changes. Okay, the y values are just greater than 0 because it never actually touches 0, it just gets really close to 0. So looking at our two examples, again we have growth and increasing. In the second one, we have what is known as exponential decay, which is decreasing. Okay, now let's look at the difference in the equations. Okay, our linear functions are only x to the first power. Okay, if you look at the quadratic functions, it has an exponent of 2, and that's the highest exponent out of all the terms. If you look at the exponential, x is the exponent. So that's how you're able to determine which is linear, quadratic, or exponential, by looking at the exponent of each equation. Okay, so don't forget to summarize what you've learned, and if you have any questions, write them down so you can ask your teacher. Other than that, have a great day, Rangers.